Okay, so good day to our fellow classmates, especially to our professor, Miss Rosemary Galanza. We are and climate change, reported from Group 4. Okay, so here are the group members, including me, John Marion F. Piñon, Donald M. Sadongdong, Rico C. Casas, Elaiza O. Delector, Leonard Moralde, Cherlyn L. Vargas, and Querly Jane T. Lopez. I would like to discuss about the atmosphere. Now, atmosphere is the layer of gases sphere, mesosphere, stratosphere, and troposphere, defined by unique features such as temperatures. Look up, way up. The clouds you see in the sky, the wind that is moving the trees, or the flag in your schoolyard, even the sunshine you feel on your face. These are all results of atmosphere. Earth's atmosphere is composed about 1% of other gases. The oxygen is necessary for most life on Earth. The majority of Earth's atmosphere is not oxygen. Earth's atmosphere is composed about 78% nitrogen, 2% oxygen, 0.9% of argon, 0.1% of other gases. Trace amount of carbon dioxide, methane, water vapor, and neon are some of the other gases that make up the remaining 0.1%. Atmospheric process. Here, where the mountain, where the where weather occurs, where in such as plants, mountains, or other objects. And the second one is the stratosphere, which is this layer surrounds an ozone layer. That it means that filters UV or ultraviolet radiation. The third one is the mesosphere, the middle layer. The middle layer. It's the coldest and it's the darkest. The fourth layer is thermosphere, the outer edge of atmosphere where satellites and space shuttles hang out. And the last one, here. Here in this picture, we see is that as the altitude changes, if we reaches into 10.5 kilometers, which is decreases the temperature. And the stratosphere is when we reach into stratosphere, which is in the temperature with atmosphere, we will we will decrease should here. When we go up in the thermosphere, the temperature increases with altitude. Troposphere. Troposphere is the lowest layer of the Earth's atmosphere. Troposphere reaching from about 7 and 15 kilometers 5 to 10 miles from the surface. The troposphere is thickest at the equator and much thinner at the north and south poles. The majority of the entire atmosphere is contained in the troposphere, between approximately 75 and 80%. Most of the water vapor in the atmosphere, along with dust and ash particles, are found in the troposphere, explaining why the most of Earth's clouds are located in this area layer. Temperature in troposphere, which I discussed in kumbaga kung ada ka ba nga ni troposphere na decrease kay may daman an ozone layer nga kon which I will discuss later, ozone layer. Okay. The next layer is stratosphere. Stratosphere, known as, extends from the troposphere upward to approximately 50 kilometers, converted into 31 miles above the Earth's surface. In the stratosphere, air temperature begins to increase. Stratosphere, to an altitude of approximately 50 kilometers, 30 miles, temperature stratosphere increase with altitude, which a high concentration of ozone, a molecule composed of 3 atoms of oxygen, makes up the ozone layer of the stratosphere. This ozone absorbs some of incoming solar radiation, shielding life on the Earth from potential harmful ultraviolet light, and is responsible for the temperature increase in altitude. Here, ozone layer, which is located from stratosphere, or found in stratosphere. Ozone layer is a region of Earth's stratosphere that absorbs most of sun's ultraviolet radiation. It contains a high concentration of ozone, or in the chemical formula of O3, in relation to other parts of atmosphere. Although still small in relation of other gases in the stratosphere, the ozone layer contains less than 10 parts per million of ozone, while the average of ozone concentration in the Earth's atmosphere as a whole is about 0.3 parts per million. The ozone layer is mainly found in lower portion of stratosphere, from approximately 15 to 35 kilometers above Earth, although its thickest varies seasonal and geographically. Ozone concentration, or O3, up to which I discussed na. And the ozone forms there by the action of sunlight that's scattered into ozone layer. Okay. In this picture, we see that this is the cycle of the ozone layer, which the sun scattered by oxygen layer, ozone layer, and the okay. The first process is the oxygen molecules are photolysed, yielding 2 oxygen atoms, but in the slow movement. And the second one is the ozone and oxygen atom are continuously being interconverted as solar UV breaks ozone, and the oxygen atom reacts with another oxygen molecule as fast movement. The third one is the ozone is lost by reaction of the oxygen atom. Sorry. the oxygen atom or the ozone molecule with each other, or some other trace gas such as chlorine. These interconversions process convection UV radiation into thermal energy, heating the stratosphere. Adi, inihiya. This graph shows within its altitude of the layer between the stratosphere and the troposphere. In this, in the graph 15, 0 to 15 altitude or kilometers, that, which is called the tropospheric ozone or the bad ozone called, or it is called the smog ozone. Yeah. And in the above of the tropospheric ozone is called the stratospheric ozone, which is the ozone layer. In this graph shows that the amount of oxygen ozone layer. Okay. So what is depletion? Depletion depleted by free radical catalysts including nitric oxide, NO, nitrous oxide, hydroxyl, atomic chlorine, and atomic bromine. While there are natural sources for all the species, the concentration of chlorine and bromine increased markedly in recent decades because of the release of large quantities of man-made organohalogen compounds, especially chlorofluorocarbons or CFC and bromofluorocarbons. These highly stable compounds are capable of surviving the rise of stratosphere, where chlorine and bromine radicals are liberated by the action of ultraviolet light. Each radical is then free to initiate the catalyze a chain reaction capable of breakdown over the 100,000 ozone molecules. By 2009, nitrous oxide was the largest ozone-depleting substance ODS emitted through human activities. The next layer from the stratosphere is mesosphere. Mesosphere is directly above the stratosphere and below the thermosphere. It extends about 50 to 85 kilometers or 31 to 53 miles above our planet. And mesosphere is dark with air pressure so low that a human could not survive in this layer. Mesosphere reaches as far as 85 kilometers or 53 miles above the Earth's surface. The temperatures decrease in mesosphere with altitude. In fact, the coldest temperatures in atmosphere are near the top of mesosphere, about negative 90 degrees Celsius, or converted into negative 130 degree Fahrenheit. The atmosphere is thin here, but still thick enough so that meteors will burn up as they pass through the mesosphere. Amo na inihiyang meteors kuno na burn up kung mas scatter diha ha mesosphere. Kay thick man niya enough kuno. Creating what we see is shooting star. Oh. Iton nga na nakita ka didat gabi. Ito hiya pag makita mo ni meteor or shooting are called as a shooting star, ito niya, di ba, nalaga na lumaga. Pag umagi hiya, lumaga, di ba? Amo na ito hiya, gin-scattered na hiya mesosphere. Yun. The upper boundary of the mesosphere is called the mesopause. While back to the stratosphere is called kuno the stratopause. Basta ito niya kuan. Pag mas scattered na ano ha, meteoroids. Next. Thermosphere. The next from the mesosphere is thermosphere. The thermosphere is typically about 200 degrees Celsius or 360 degrees Fahrenheit hotter in daytime than at night. And roughly 500 degrees Celsius are converted into 90 degrees Fahrenheit hotter when the sun is very active than at the other times. Imagine, thermosphere nga waray pa kumuanhan hansan kung kumadto ka mo your area. Ito nga kuan kapaso 200 degrees Celsius. Imagine maka luto na daw kamong cake di ba? Kaya kung saan kuno magkuan mag-appear di daha thermosphere kung naa ka area. Mga higher na ito into 500 degrees Celsius. Thermosphere is located above mesopause and reaches out to around 600 kilometers or 372 miles. Not much is known about thermosphere except that temperature increase with altitude. Solar radiation makes the upper regions of the thermosphere very hot, reaching about temperatures as high as 2,000 degrees. Oh my gosh, kahat ito day. Mas hot pa sa crush ko. Okay. The uppermost layer that blends with what is considered to be outer space is exosphere. Oh, I forgot Aurora Borealis. I will discuss it now. So, this is my favorite part of discussion, which is the Aurora Borealis, also known as a polar lights or Aurora Polaris, is natural light display in Earth's sky, predominantly seen in high latitude regions around the Arctic and Antarctic. Auroras are a result of disturbance in magnetosphere caused by solar wind. This disturbance alter the trajectories of charged particles in the magnetospheric plasma. These particles, mainly electrons and protons, participate into upper atmosphere. The resulting ionization and excitation of atmospheric constituents emit light of varying color and complexity. The form of aurora occurring within bands around both polar regions and also dependent on the amount of acceleration imparted to the participating particles. Most of the planets in the solar system, some natural satellites, brown dwarfs, and even comets also host auroras. The causes of The next one is exosphere, which I mentioned as a last layer of atmosphere. Exosphere, the thermosphere to be outermost layer of atmosphere. Others considers the exosphere to be the final frontier of Earth's gaseous envelope. As you might imagine, the air in the exosphere is very, very, very thin. Meaning, waray nahiyag gas amount and concentration nira, making this layer even more space like than the thermosphere. In fact, the air in exosphere is constantly, though very gradually, leaking out of Earth's atmosphere into outer space. The pull of Earth's gravity is so small here that molecules of gas escape into outer space. And there is no clear-cut upper boundary where the exosphere finally fades away into space. Different definition place the top of exosphere somewhere between 100,000 kilometer or 62,000 miles and 190,000 kilometer or 120,000 miles above the surface Earth. The latter value is about halfway to the moon. So these are the last layers from the Earth's atmosphere. The next one reporter is Donald Sadongdong. Can you please discuss this slide?
Okay. Thank you, John Marion. I will discuss the gravity and atmosphere pressure. So the stronger gravity, the more gases is held by the world, and the greater the weight of atom on POI or top of atmosphere. This is a graphical picture with the weight of air in columns apply the pressure to point X in the below of the unit area in the surface. Next slide please. Atmospheric pressure. These are three types of atmospheric pressure. Number one is the gases pressures depend on the both density and temperature. Number two is adding the air molecules increasing the pressure in the balloon. Heating heating the air also increases the pressure, like in the balloons. When you uh locking the balloon inside ang sulod bahan balon kung magkukuang ka kunig nagkuka mo sulod di ba sa hangin na sulod man kunig kunig lalak mo ni an exitan balon tapos igaplay mo hin hin kalayo diri mo asin tututukan kalayohan balon na kung possible bumoto talaga to ito kuan ani ito gases naging gagawasan kalayo ang hangin liwat sa akog, balot nagkakalisang na gusto ko mawala. But gusto mo tumakas ba para makalupad? Next slide please. Ciao. John Marion. What do atmospheric properties? Variety with altitude. So this is the graph of invisible altitude. Mm, This is the blue one. This is the visible. And the UV is the purple and the X-ray is the green, light green. In the visible is the altitude is about to 0 to 350 altitude, and the UV ray or the ultraviolet ray is about to 50 to 350 altitude, and the X-ray is about is 100 and 350 altitude. Next slide please. The light effects on atmosphere. There's many types of lights of effect on atmosphere. Ionization or radiation removal the an electronic. This so dissociation or destruction of a molecule. Scattering. Scattering is changing the photon's direction. And, the last one is absorption. Photon energy is absorbed. Next slide. Next slide. As atmospheric process. Gaining and losing the atmosphere. This is the most important. Against or gains are volcanic outgases, impact, and evaporation. Losses the gas escape, the impact, condensation in the surface. Greenhouse effect. Interpret the energy and reflected back to the ground by carbon dioxide too. In atmospheric circulation or convection calls to move the gas from equator to the pole back. Coriolis effect. The gas are dragged sideways by the radiation rate of the world. Next slide. This is the picture of as atmospheric gains. When the volcano erupt, the smoke is outgassing, and the waters are evaporation or submission, and the boomerang or the call this yeah, gas or the emission from others. Okay, next slide. This atmospheric losses. The thermal escape. The thermal escape is like they are wide, and the barber boomer
Bombardment.
bombardment is the causes the thermal escape. Atmospheric creating like a meteorite goes down in the earth. The impact of gases will be raised up to atmospheric to creating the dark clouds. Condensation. The condensation is like in cooling down, and the chemical reaction gas combined with the surface or materials. Next slide please. Greenhouse effect. The greenhouse effect is visible light passes through the atmosphere. The greenhouse gases trap the interfered radiation in atmosphere, hitting the lower atmosphere. This is the visible, the yellow line, and the greenhouses trap inherit the interfered the radiation in atmosphere, or the heating the lower the atmosphere. This next slide please. Atmospheric process. There are ways of adding the atmosphere for the four ways of depleting it. Gases and molecules can transfer out to space or down to the ground. How does the greenhouse affect the warm planet? The atmospheric molecules allow the visible sunlight to warm at the planet's surface but absorb the interfered photons or trapping the heat. Next slide, please. As atmospheric circulation, the convic- convection or the circulation of the atmospheric heat area arises at the equator, and the cooled area is in the poles. The heated air rises at the equator is maximum or the sun are warming. So the southern hemisphere circulation is will be slightly heat and the northern hemisphere circulation is cold and the equator is the cold air descent at the poles. So when the sun sun maximum heat will be moved to southern hemisphere down to pole and the northern hemisphere circulation cell is will be colded to heated. Next slide please. Cor huh? Cor Coriolis
Koy-
effect. Ang kanay na.
Kuya ka na to.
Oh, sorry.
Okay, the next reporter is Querly. So, Curly, can you discuss it? This slide thing.
Okay, so Coriolis effect. It is the force which deflects the direction of wind. This force is caused due to rotation of the Earth and is at the equator and maximum at the poles. So next slide. In Coriolis effect, the it deflects north-south winds into east-south winds. So in northern hemisphere, object deflects to the right, while southern hemisphere, object deflects to the left. Next slide po. Coriolis effect breaks off global circulation. On Earth, the large circulation cell breaks off into three smaller ones, moving diagonally. Other worlds have more or fewer circulation cells depending on the rotation rate. Next po. So there is the different rotation of Coriolis effect. First, the quick rotation. The winds blows north or south. The second is moderate rotation. Winds are diagonal. The last one is strong rotation. The winds blow west or east. Next po. So the total atmosphere circulation. The total atmosphere circulation, this model is based around cells. These cells are regions where the air moves the low pressure to high pressure. So in atmosphere circulation, there are three cells in each hemisphere, and these are the Hadley cell, Ferrel cell, and the polar cell. In Hadley cell, warm air at the equator rises and then cools in the upper atmosphere, then circles back down towards the tropics. While in Ferrel cell, it moves in the opposite direction to the air in the Hadley cell with warm air moving toward the polar regions. The warm air that has traveled up from the equator converges with the cold air that has traveled down from the polar regions. As the air converges, the warm air is forced to rise and move back towards the equator. And lastly, the polar cell. The overall effect of the polar cell is to move cold air towards the equator. So the Hadley cell and polar cell are controlled by the sun's heat, whereas the Ferrel cell is controlled by the two cells. Next po. The atmospheric process. What creates wind and weather? Atmospheric heating and Coriolis effect. Solar warming creates convection cells. The Coriolis effect drags wind sideways and breaks off the cells. The faster a planet spins, the more EW gas movement. So that's all for my report.
Sige, the next presenter is Cherlyn Vargas. This topic is weather and climate. So, Miss Cherlyn Vargas, can you discuss this topic?
Okay, let's move on. Weather and climate. Next slide. Weather and climate. Weather is what the forecaster on the TV news predicts HD. They, they tell people about the temperature, cloudiness, humidity, humidity terms. It is the mix of events that happens each day in our atmosphere. Weather is not the same everywhere. It means hot and sunny in one part of the world, but freezing and snowy in another. Next, next po, radiation. The flow of electromagnetic energy between the sun and the earth's surface as it is the influence by clouds, aerosols and gases in the earth's atmosphere. It includes both solar radiation, sunlight, and long wave or thermal radiation. Next, water cycle, also known as the hydrologic cycle or the hydrological cycle, is a bio, bio, wait lang, kay kasi. Biochemical cycle that describes and continuous movements of water on above and below the surface of the earth. Next, next po. Evaporation. Types of vaporization that occurs on the surface of a liquid. It changes into the gaseous phase. The surrounding gas must not be saturated with the evaporating substances when the molecules of the liquid collide. They transfer energy to each other based on how they collide with each other. When a molecule near the surface absorbs enough energy to overcome the vapor pressure, it will escape and enter the surroundings air as a gas. Next, next na po. Condensation. Change of the state of matter from the gas phase into the liquid phase and is the reverse of vaporization. It, it can also be defined as the change in the state water vapor to liquid water when in contact with a liquid or solid surface or cloud condensation nuclei within the atmosphere. Next na po. Precipitation. In meteorology, precipitation is any product of the condensation of atmosphere water vapor that falls under gravitational force pull from clouds. The main form of precipitation includes drizzling, rain, sleet, snow, ice, pellets, groupil, and hail. Next, nitrogen cycle. The biogeochemical cycle by which nitrogen is converted into multiple chemical forms as it circulates among atmosphere, terrestrial, and marine ecosystems. Next na po.
Okay, the next reporter from this slide is Mr. Leonard. Mr. Leonard, can you discuss this slide, please? Thank you.
Weather and climate. Cloud classification. Clouds are classified according to their height above and appearance. Texture from the ground. Example of cloud types is cumulus. They are puffy, white flat bottoms, and they are vertical motion. And stratus, layered, low altitude, and horizontal motion. While the cirrus cloud is thin, feathery, white, and also it has an high altitude. Next slide po. So in this picture, we can see the different types of clouds and their altitude and also their shapes. Next po. Cumulus clouds look like piles of cotton balls, while stratus clouds are not as tall as cumulus cloud but they are covered more area. While cirrus clouds are made up of ice crystals and like a feathery types of clouds. Next po. Cloud types. The following cloud roots and translation summarize the components of this classification system. Zero means that curl of hair and has height. So the cirrus cloud has curly of hair and it is thin thin clouds and has a high altitude, while the alto is mid, not too far from the earth and not too close from the earth. While strato means layered clouds, and nimbo means rain and precipitation. Cumulo heap also means layered clouds. Next po. Clouds and weather. The clouds that gives poor weather are the cumulus and stratus produce precipitation, but the cumulus and stratus only produce little to non-rainfall. So it only gives light rain to none at all. While the cumulonimbus and nimbus stratus clouds gives the severe weather like thunderstorms and also it has it causes snow, hail, rain and ice pellets. While fair weather is serious indicate good weather. That's all.
Okay, so the next slide is the okay. The next slide from this discussion is from Mr. Rico Casas. So Rico Paul Casas, can you discuss this slide,
Okay,
please?
thank you and good morning. My topic is climate change. Climate takes hundreds, thousands, even millions of years to change. This graph shows the describes with the graphs. These they are known as climatograms. Next, please. Wait, it's kind of like malabo. So the
I
image
think
shows
it's
that
okay.
okay.
Proceed.
So the image shows that the area which facings the sun has different weather. Thank you. Next slide, please. These are the things that are used to study weather. Weather stations have meteorological instruments to get information about the weather conditions. Some of these instruments are thermometer, barometer, rain gauge, and wind are weather vanes. Next slide. Climate. Altitude refers to the vertical distance between the lowest point and the highest point of an area. A land's altitude is calculated by the measuring distance from sea level to the highest point. As we go higher and higher, the climate becomes colder. Next slide. The distance from the sea, land heats and cools faster than the sea. Therefore, coastal areas have a lower temperature range than those areas inland. On the coast, winters are mild and summers are cool. In inland areas, temperatures are high in the summers and cold in the winter. So the map shows the different colors and describe different temperatures. Thank you.
Okay, the last reporter from this group is from Miss Liza. Miss Liza, can you please discuss this slide? Thank you.
Okay, thank you. Severe weather. Thunderstorm. Strong severe storm that produce lightning and thunder. Lightning electric discharge up to 54,000 Fahrenheit. Thunder shock wave produced by lightning. Also produce hail, high winds, flash floods, and tornadoes. So lightning hits the air around it to incredible temperature as hot as 54,000 Fahrenheit, and it almost converted into 30,000 degrees Celsius. So, that's the 5 times hotter than the surface of the sun. So, kung makuha ka tamaan ka ba ito na kidla, ito na thunder, syempre, mapaso-paso ang good ito. Matoto na kadayon. How did get as in? So, if we are watching the sky, we see the lightning before we hear the thunder. That is because lights travel much faster than sound waves. Next slide, please. Tornadoes. What are they? Spinning column of air with high wind speeds and low pressure that touches the ground. How they deform. Funnel clouds box out bottom and cumulonimbus cloud becomes tornado when it touches ground. How are they measured? Fujita scale 1 to 5 based on damage. So Fujita scale is a rating, tornadoes intensity based primarily on the damage tornadoes. In fact, on human-built structure and vegetation. So nagme-measure ako nit intensity tornado. Sige, next, please. Hurricane. How they deform. Series of thunderstorm over tropical water. Winds in different direction cause storm to spin. And wind speeds range from 120 to 150 km per hour. How are they measured? Saffir-Simpson scale 1 to 5 based on winds and storm surge. So, a hurricane is a type of storm called a tropical cyclone which forms over tropical or subtropical waters. When a storm maximum sustained wind reaches 74 miles per hour, it is called a hurricane. So kanina 'di ba ang thunder tapos ini na hurricane bagat magusalera kay suad ko na bagyo na kuan man liwat natan nakidlat. So that's why nagkakakosin ko anin flash floods. Awin mga kuan mga storm surge. So the Saffir-Simpson hurricane's wind scale is a 1 to 5 rating or a category based on a hurricane maximum sustained winds. So that's all of my report.
Okay, Miss Elaiza, thank you for the discussion. So we are done now in our report. So the next slide is about the drill quiz. Then I will send it later when the video was uploaded. And that's all. Thank you.